This is Don Turner, Federal Sales Director at Patent LLC. Today I'm going to be discussing the Patent SFX Cyber-SFP module and its applications. We will examine the key features and advantages of the Patent SFX Cyber-SFP module over competitive offers. We will review what a data diode is intended to do from a functional perspective and look at some sample application scenarios. Then we'll close with the current pricing and roadmaps for the SFX Cyber-SFP family. First and foremost, Patent SFX devices are manufactured in the USA, specifically Gaithersburg, Maryland. A key differentiator of the Patent data diode solution over the competition is in the form factor as a small form pluggable or SFP. The Patent SFX is built from milled brass for both durability and EMI RFI containment. The brass enclosure also has a physical block on the return path, making it impossible to connect incorrectly. There is no physical return path. Fully compliant with SFP standards and specifications makes it a universal fit that's a very low consumer of power at less than 800 milliwatts. Tested by the highest security evaluation body in government, guarantees that the Patent SFX Cyber-SFP operates as advertised. Data diode solutions come in many forms. Some are applications that reside on a physical server, while some are dedicated appliances. These solutions tend to be very expensive, but do offer some significant advantages in advanced content filtering and analysis of the data being sent in the one-way path. However, that capability comes with an increase in cost, deployment complexity, programming, size, and weight. Some customer applications simply do not need that extra layer of complexity. Customers just want to send the data in one direction and make it as simple and cost-effective as possible to deploy. The other advantage of Patent using the SFP format is its portability. As needs change, it's a simple matter to unplug and reconnect the module to a new requirement. Because we are just forwarding traffic, we can also realize greater speeds than other solutions. Patent diodes are performing at 10 gigabits per second today, and we have line of sight to introduce a 100 gigabit model very soon. So, what exactly is a data diode? Simply put, it's a solution that securely transfers data between differing environments, but only in a single direction. This has applications in cross-domain use cases for transfers between two networks of two different security classifications. But it can be any connection that's required for only one-way transmission. The diode itself is simple. The secret of their usefulness is in how they are deployed. This unlocks them to do what we need them to do and to protect what we need to protect. In the U.S. military and intelligence communities, data transfers from low to high or high to low security domains securely make data available to more people. This is by far the most common use case for data diodes. They utilize specially accredited and controlled cross-domain solutions, which are verified to send data from one security domain to another domain of either a higher or lower security. This could be from a UAV in the field to a secure enclave, or from a soldier in the field to a ground station, or even from one secure network to another in the same building. Data can traverse from unclassified to secret, but there is no permitted traffic from secret to unclassified, thus protecting the secure domain. In some cases, limited bidirectional communication is still necessary for operational confirmation or for command and control. The U.S. Department of Homeland Security advocates using a single open port over a restricted network path to severely limit the attack surface, or the area between the stations in the diagram. A bilateral solution includes two independent data diode one-way paths that permit a single round-trip session between pre-configured IP addresses. This provides one-way data transfer responsible for outgoing traffic and another for incoming traffic. In this example, the data from the outstation is continually sent to the master station for monitoring current conditions. The master station can then send control signals to the outstation to adjust and change settings as needed. The data in each direction is protected through the innate restriction in the network paths. Determining exactly where data diodes should be deployed depends on the specific security goals. If the primary goal is to protect the source network, then the data diode is deployed at the edge of the security border of that source network. The data diode at the network boundary in the red circle on the left diagram prevents any possibility of an external party hacking into the source network while still making the data available to someone outside of the source network. In the example on the right, a power plant may need to control access to the facility to prevent breaches or the hijacking of controls. However, they may have multiple data connections to external end users in order to transfer data for supervisory control and data acquisition or SCADA systems, historian databases, or to provide a remote human-to-machine interface connection. If all these connections are isolated to a one-way transfer through the data diode in the red circle on the right, that sends data off-site, the power plant's operational technology network will be secure from an external cyber threat, while the critical data is made available to necessary external end users. It may be the primary goal to protect the destination network and prevent unauthorized data access, removal, or corruption. In this scenario, the data diode is deployed at the security border of the destination network. Data can be transferred into the destination network, but cannot be accessed, removed, or leaked back through due to the one-way path provided by the data diode. A cybersecurity forensics laboratory, as shown on the left, may need to analyze forensic data, including malware samples, in a forensic database, without the possibility of that data being leaked or contaminating to other systems. In this case, the data diode is placed in front of the forensic database, and all other external connections are eliminated, mitigating data leaks and any potential malware propagation. If the goal is to protect both networks, one-way hardware is typically applied at the security border of both the source and the destination networks, creating a single, isolated path through which all data flows. The example on the right shows a bank with multiple branch offices, with each branch sending data back to the corporate headquarters. The headquarters may want to make sure that that data is not accessible to any external sources. In this case, a data diode would be placed at both the edge of all branches to allow data to be sent out with no access in, and placed in front of the database at headquarters to allow data in, but not out. Many believe that remote monitoring cannot be achieved without some remote access to systems. However, as previously stated, if remote access is provided via an external two-way connection, then a threat vector is created. By utilizing data diodes, a high-security network such as an oil and gas refinery is secured by one-way transfer hardware, preventing all external access. Meanwhile, the data required for remote monitoring, backup, or analysis is sent one way safely to another network or to the cloud, where end users and applications can access it as needed without compromising the integrity of the refinery controls. Data is sent through the data diode to a repository where external remote users can securely access that data without having to retrieve it from the actual site. On the diagram, you'll note OT network. OT is operational technology, and these networks provide infrastructure such as manufacturing, utilities, and defense, as well as a building infrastructure that operates key facility systems such as lights, elevators, heating and cooling systems. OT systems monitor and ensure the safety of these operations. An OT network, for example, may monitor a switch and trigger a shutdown if a certain value is exceeded. While OT systems run on critical infrastructure, they paradoxically often run on aging software and obsolete hardware, which makes them difficult to patch and highly vulnerable to exploits by malicious actors. This shows the current MSRP pricing for the current SFX Cyber-SFP models with single-mode fiber connections and 1 and 10 gigabit speeds. Multi-mode versions of these are also available. The diodes should be purchased in pairs, one transmit and one receive for each communication path. And again, 100 gigabit models are in development. So what can patent SFX Cyber-SFP modules do for you? Is there a unique set of data and information that you need available yet fully protected? The power of the solution is in its simplicity, cost, and flexibility, being able to change and adapt as your protection needs change. Without any complicated programming, these can be deployed for simple data transfers between domains. The actions of the patent SFX Cyber-SFP have been tested and verified by the highest governing security agency, the NSA. The standards-based form factor make them universally deployable in switches, routers, and servers, anything with a standard SFP receptacle. Best of all, built from milled brass right here in the USA. Let's connect and talk about your applications. Thank you.